Okay, so let's start with the exercises. So just a quick reminder or a quick recap on what we've done. So it was so calculating the determinant is very important to actually calculate the inverse and to solve linear equation problems. Simply because it's involved in the inverse, and it's very important to get the inverse of the function. Especially, I mean, we're talking about 2 by 2. Anyway, so it was also important for us to see that the determinant. Well, I'm not sure if you can calculate the inverse of function using the determinant if it's more than 3. I mean more than 2 by 2, but anyways, let's just assume that for now. And I don't think, because we have other alternatives to get the inverse of a function, mainly using the identity matrix, and um, if it's a 2 by 2, we can always go for the determinants. We can also get the inverse of function using minus conjugate the minus and conjugate stuff, cofactors and conjugate. So you would get the determinant of you would get the determinant just like we've for the matrix for each of varying elements. You put it in the right spot. You do a checkboard thing, like change the signs. Every positive has a negative next to it, and then you would transpose, and then you would get the determinant of the full function, the original function, I mean. And yeah, so getting the determinant function 2 by 2 is quite straightforward. It's really straightforward. When it gets a bit tricky when it's 3 by 3 or more. So if it's 3 by 3, take each element, get its rows. If it's 4 by 4, you get that element, you get a matrix of 3, and then you do the same. So that's called Laplace expansion. It can get really complicated really quickly. So let's see the set of examples we have. We have 10 questions, and hopefully we don't face any like 5 by 5 matrix or something. Anyway, so it's our luck that we've got a 2 by 2 matrix. So okay, I got my paper ready, and okay, so this should be straightforward. So this has to be, so this is, we have so we multiply this by this minus this by this. In that sense, okay. Okay, so we have minus 6 minus 5. So we get 9 minus, so 5 by 1 is minus 5. It's actually minus 11. So let's see if the right answer. Okay. This is 3 plus 10. That's 13. That's straightforward. I have a feeling that it might get escalated really quickly. So we have minus 4. The second one, so we have minus 4 minus 24. That's like plus, that becomes a plus, so plus 24. Then you get a 20. See? Yep. So we have minus 2, 4. That's minus 24. Minus plus is good. Now this is, we have 15 minus, so that's plus 4. Then we get a 19. Sweet. Things are a bit easy for us. I don't want to jinx it. Anyways, so that's a 10 plus, so we have a 10 plus 12 plus 22. Oops. So 5. Oh, it's actually No, it's actually not right. Actually, minus 2 because this changes the signs. We really have to be careful. Now, this is where it gets a bit tricky. So let's try to solve this one. I don't think we should like spend a lot of time on this, but just do it for the sake of knowing it and just be familiar with it if it ever, if it ever presents itself. Okay, so first of all, we need to get the determinant for like get each element on its own. So we have the 3, we ignore the columns and rows, so we have minus 15. So we will be having, so we have 3 multiplied by minus 15 minus 4. And then we would do a negative sign, remember. So there is a 0, then it's a 0 by default, plus. So the signs are interchangeable, remember that. And just to really quickly double check on it, yeah, so the signs minus and plus, if it grows bigger, then you'll have to do minus, plus, minus, and so on. Minus, plus, minus, and on with it. Like, anyway, so that's that. Let's go back to our main question and keep on with it. So, and one thing else is that we always multiply by the determinant that sorry, the variable that we would be. Yeah, that one. So the negative one, we will ignore these and these, so we'll have 2, a 2 minus, so it's minus 15, minus 15 minus 1, so minus 1 multiplied by 2 minus 15, and then we would solve accordingly. So it's a 3 multiplied by minus 19, so this is we would have minus 13, so plus 13, and that would give us so let's multiply 3 by 19, that will give us 57 plus 13 is minus 57 plus 13. So if we are to subtract it, so we'd have minus 44. That's the determinant. Yep. So we got A, B, C, D, E, F, G, H, I. So we have A, B, C. This is also really important. So we have A, B, C, and then we solve accordingly. Basically what we've done. Alright, so do we need to do another one? Let's do another one. It's quite easy to be honest. So 4, 2, and minus 1, minus 5, 3, and minus 2. So taking the first row, we have 2. So we have 2 multiplied by minus 4 plus 3. And then we have minus, so minus 3 multiplied by 5. 5 minus plus 8. Then plus the third element on the first row, which is 1. So we would go for minus 10, minus 12, minus 10 minus 12, multiplied by 1. Okay, minus 10 minus 12. Now let's do this. So we have 2 multiplied by negative 1. So minus 3. That will be a positive, plus 3 multiplied by 13, and then we would have plus minus 10, so that's minus 22. So now we fix up the signs. We'll have minus 2 plus, so we have minus 2 plus, we have 3 multiplied by 13, give us 39 minus 22. So minus 20, so it would be 39 minus 24. So that's 39 minus 24. So that's a 15. It's 15. Something I've done is wrong. Let me really quickly revisit my calculations. So minus 4, this would yield minus 1. So that is correct. And then minus 3 multiplied. So for the minus 3, we eliminate. We'd have minus 5, which is plus 5. Oops. Oops. Yep. We've actually had a mistake there. It's actually minus 15. I figured what the mistake was. What? Yeah, it's actually minus 19. I know what my mistake was anyway. So my mistake was when I got B, I calculated it. I multiplied f by j minus d I, which is I'm supposed to do it the other way around, which is d multiplied by I minus f by j. Let's do another one. Okay, so we have 5, 1, and negative 2. We have minus 1, 0, and 4. We have 2, minus 3, and 3. So if we take an element, the first row, so the first row would eliminate the other two. So it'd go 5, 0, minus 12, that's like multiplied by 12, minus 1 multiplied by negative 3, minus 8, plus negative 2 multiplied by, we have a minus 3, that's a 3, minus 0, so that's that. So we would do 12 multiplied by 5, that would give us 60. 5 by 10, 10, 5, 1, 60. Minus 3 minus 8, that's like minus 11. Minus 11. So that's plus 11. Okay. And then minus 6. Minus 6. So the 11 minus 6 would yield, so we have 60 plus 5, 65. The answer is actually 65. Yeah, got it. Got a question. So let's solve this again. It really does take a lot of paper. So we have 2, 0, and negative 1, and then we have 3, 5, and 2. We also have negative 4, 1, and 4. Now if we take the first element, which is 2, so 2 multiplied by 20 minus 2 is 18, minus 0, let's ignore that, plus we have negative 1 multiplied by, we have 3 minus 20, so that's plus 20. Now, so we have 2 multiplied by 18, then we have minus 23. So 18, if we multiply, that's 2, 16, 36, minus 23, 13. So nice, I think we've got the hang of it, so let's do the last one. So we have 2 minus 1 and 0, then we have 3 minus 5 and 2. I was actually expecting this is going to be like a really long set of steps, but like it's quite straightforward. So we have 2, we multiply it by negative 10 minus 8, especially when you like really write it down. So we have minus, so we have minus 1, negative 1 multiplied by negative 6 minus 2. It's very important to have the cross, like have the left side and then you go with the right side. It's just like keep mixing those together. Anyway, so we have a plus and then a 0, so that's actually eliminated. And I have a sense that also these guys are really have simplified examples for us. But anyways, it doesn't really matter. So minus 10 and minus 8, that's minus 18. So negative 2 multiplied by 18, that should give us a negative 36. Okay, so minus 6 and minus 2, that's actually minus 8. Multiplied by minus 1, that's actually a positive, so minus 8, so 36. So 36 minus, so minus negative 36 minus 8, that we should give us the addition. So we have a 4 for 40, so that's negative 44. No? What did we do wrong? Let's see, very quickly revisit the signs again. So we have 2, you have, no, negative 5 multiplied by 2, that's a positive 10. I'm not sure why did I have that negative 10. I'm not sure why did I make such a silly mistake. So my mistake was when I took A and multiplied E with I, for some reason I kept the sign, and they are both negative, so negative 5 by negative 2, that should yield a 10. And I for some reason wrote it down as negative 10, which is supposed to be a 10. Let me try to redo this real quickly. You can't have the last question be a wrong one. 3 minus 5 and 2, 1 for negative 2. So we have 10 minus 8, and then the rest should be the same, I believe. So we have minus 8 for the second part, and then we would have 10 minus 8 is 4, so 4 minus 8, that would give us a negative 4. So the answer is actually negative 4. Oh my man, done it wrong again, whatever. So I actually got 3 wrong questions. So that's that with this one, determinant of matrix. Wasn't that bad if you ask me. And determinant, I think we should add this as a resource to the list of resources that we have and we're building. So we have these determinants, higher ones. We could go like this, create a bookmark. I think we should really reorganize this in a way that really gives us more view, because you know it's kind of leaning towards studying multiple, or you can live it this way. It's like there are a lot of topics to cover at the same page, and the raw echelon form, and you know the beauty of all of it. Now, why is this here? 3 by 3 matrix. No, this is wrong. Because I believe it was somewhere around here that we had it. Yep, that's this one. Okay, so what should we study next? So we've done this, the determinants, inverse of a matrix. So basically this is what we used to do. This is a really nice set of exercises. Okay, so what else? Matrix, determinant of matrix, that's something we've covered today. Matrices, let's see what matrices, if there's anything else we have missed. Matrices, we've done all of the goodness of these. Multiplying, let's see the multiplying. Applying scalar, you get it in there, and then you solve. Matrix determinants, okay, this seems pretty, okay. Apple cherries. Yeah. Nice, so the dot product has to be next, I guess. The dot product is our next topic of discussion. But before that, we have to start with the revisions that we've covered so far. I think that covers most of the stuff that we have on matrices. Solving systems of linear equations using matrices. this should be our next topic, I guess. We should move this here. So the inverse using elementary, and then we have the inverse using inverse may not exist bigger matrices compared to larger, and then visual computer, Gauss elimination. Yeah, we've done all of the rest of the good stuff. And the inverse of matrix is something we've also covered. Methopolis. I think Methopolis is pretty... I've never checked this site, to be honest, but I think I'll check it out now. I'll just end the video here, and then we'll start the next video on solving systems using matrices. I think this should be quite an interesting one, where we have different variables and systems of linear equations. And then, so after this one, it's all revisions here on. So we just have this topic to cover next on the next video, and then the rest of the journey is all about solving the actual problem, going through the different topics we've covered. We've covered a pretty good chunk, if you ask me. So we have to go through the different numbers, sets, functions. Remember the functions, we have the equivalence functions, and then we also have different types that we don't want to forget about. So we have to revisit them. Equivalence relation, which is of the functions, and we could maybe have this one like below this. So functions, like what happened. Equivalence relation, yeah, that is the page we're looking for. Equivalence relation, then we have the slope, we have percentages, parabola, matrix, all the good stuff. Alright, so I guess we just have to stop here for this video. So we this video is a quick recap. We've done some exercises on solving, getting the determinant of more than 2 by 2 functions, as well as matrices, as well as the 2 by 2 matrices. The determinant is quite important to get the inverses, and I'm not sure, it's gonna be quite hectic to get the determinant of functions on. I'm not sure if you can get the inverse of function using 2 by 2 because you need to flip the signs and all. But this is important to get the inverse of function using the minors. We've seen how to get it. It's not really straightforward. We have to use the minors, cofactors, and conjugate, of course, and then we multiply by half. Not by half, 1 over the determinant. So, like super quickly, for 2 by 2, we just get the determinant, and then we do the swapping and flipping on the matrix itself. If it's more than 2 by 2 matrices, then we will have to use a different approach. Either we use the identity matrix, or we use the minor conjugate and the cofactor and conjugate method. So just to make this set or minor cofactor conjugate. Was it conjugate? What was it again? We've had it somewhere here, I'm certain of that. Educate, sorry, not conjugate. Got the link. Not sure what I was thinking. Okay, so we can use those. Well, for 2 by 2 Okay, so regarding the determinant, we pulled this. It's obtained from square matrices. Okay, so we'll stop this video here, and then we just need to do another video on just the other video would be on solving systems of linear equations using matrices. This is something we've already covered, but it looks like we have when we have various variables that we could work with, we could actually start on with that. All right, have a good day.